Hello, everyone. Today, out of the 5,000 buildings that are built every day, we want to talk about just one and our story on that building. That building is, well, definitely a special one for Dubai, and a special one for technology and for what we're talking about today. The building is a vision from Sheikh Mohammed, and is a vision from the Future Foundation of Dubai. And it's a vision about a message for the future. The facade itself, the windows cut in the facades are a poem written by Sheikh Mohammed, and it's a message about the future. And the building, which is designed architecturally by Killa Design, it's really an icon for Dubai, an icon for technology, an icon for what can be done. But apart from being an icon, clearly it is a building. It is a building that needs to serve a purpose, that needs to serve exhibition, labs, offices, and exhibition areas, and it needs to work as such. It needs to work with obviously all the services. Water needs to be in the building, electricity, air, and it needs to stand up, obviously. It needs to stand up through its structure, through what makes it a building itself. And it's the concrete, and it's the steel around it, which if you haven't seen it already, I suggest you drive or you take the metro on Sheikh Zayed Road. There is a beautiful view of the building, half built at the moment because it's under construction, and it's quite stunning. But the message really is that apart from being one of the 5,000 buildings being built today, it's a complex one, and complexity is whether you realize it or not, when you work on something complex, you're pushing the boundary a little bit of what's possible, and also you have a glimpse of what future technology will be and will be applied to buildings. Now, at Bureau Happold, that's what we do. Effectively, we apply engineering and design thinking through technology to solve complex problems. And we solve complex problems in buildings, stadia, convention centers, office buildings, and in cities at city level. And we've done it for several years. It's, the Louvre is one of another example here in the region. The railway station in Riyadh is another example here in the region. But realistically, all these projects, the common thread is, they've done through pushing technology a little bit further every time. And in this case, obviously, we wouldn't be here if the answer of how do you engineer the future wouldn't be part of the discussion today. And clearly, part of the answer is, BIM. BIM is part of the answer. A building like this, I'd say, wouldn't be possible without the use of the latest technology, with the use of BIM technology, of a 3D model that really explains the complexity of the building and shows it in one go, instead of having to do drawings and to try to convey complex message with tools that are really not up to the task of conveying complex messages. You can see it only through two simple sections of the buildings, how many things are happening at once. This building is not a large one. It's only about 25,000 square meters. And yet there are a lot of things happening. There are different spaces. There are elevators cutting through the shape. There is the facade, a 3D facade that sometimes is in, sometimes is out of the building. There are spiral stairs. And it's because of this complexity that, it's paramount that everyone, every single discipline, every single specialism is able to coordinate and confront the other disciplines in the same environment. And the environment, obviously, it's a 3D space. It's a 3D space in the cloud. It's a 3D space where our team delivered something like 27 different disciplines, plus architecture, plus now it's being implemented on site. And everyone, every single discipline, every single office, and we worked throughout the clock on 12 different time zones. The model was prepared in Dubai, then sent across the globe so that we could work on the model 12 hours a day with different teams, with different specialisms. And everything was done through the same model that was accessible to everyone at the same time, all the disciplines. And not only that, imagine reviews with the client, with Meras, who are the development manager, and Dubai Future Foundation, who are the clients. Well, instead of having to print every time drawings and everything like that, reviews happen automatically. The client can download the model, can even access the model online and do the reviews every day. Whatever they want to do, whatever they want to check is there, it's available, and it's ready to be reviewed. So it allows for the review system to be seamless and really integrated in the design process, and not a milestone that at times can be, well, difficult for both parties, for the designer and for the client. Now, apart from using the model, the 3D cloud-based model, to coordinate with different disciplines, of course, we saw it in a presentation before. Each different discipline need to be able to tap into the model and to extract the right information from the model in order to run their models, in order to run their scenarios. This is just, I'm going to show you two examples. The first example is about structural engineering, how our engineers effectively created a seamless loop between the BIM model and the analytical model so that we could change elements in the BIM model through coordination with architecture and other disciplines, and the same change would be reflected in the analytical model, and vice versa. We could find the best solution analytically and implement it directly into the BIM model. The same was done for other disciplines, effectively for all disciplines, but showing you 27 disciplines would be quite boring, so only two. This is CFD modeling and evacuation modeling. Same thing, the BIM model, the spatial characteristic of the building were exported into the CFD modeling software, which was able to do the CFD modeling for smoke in case of fire. And that was even looped with the evacuation modeling that studied how people could move and could escape through the building. And all that was, again, seamlessly looped into the BIM model so that we could change the BIM model as we were doing our analysis. And this is just another example of what's possible to do. It would be very difficult with other technologies to show everything at once, to have all the systems in the building showed at once, to clearly show and make people understand where the different systems are. Obviously, this is quite complex to understand or to even read because everything is shown at once. But imagine being able to do a review of a single system so you can from one model, from one place, understand where it starts from, what it does, and where it finishes, which is quite unique and it's quite interesting in terms of, again, reviews and understanding how the building works. Realistically, though, nothing of what I said so far it's particularly advanced. It's effectively implementing 1992 technology into today's world. And the key issue, yes, there is the cloud, which is the add-on component, but we are applying what BIM is, which is 1992 technology. So what's next? What's the 2017 technology? What's exciting about it? And again, part of it was in previous presentation. First is the first part of added value, I'd say, is the generative component of modeling. So the model itself, the structural grid in this case, is an output of engineering thinking. Our engineers don't spend any time drawing the model into the BIM platform. They spend time encoding what the model should do. So what are the core principles of the structural engineering in this case that should be considered when preparing the model? And then, well, then the model prepares itself and it's created following engineering rules and following design processes, but not by us, by the machine. And it's not only is generated, but I hope you can see the other model, the one on the right, is moving as well, but it's relaxed, which means at times the rules that we give are too strict. So we need to be able to relax them, to play with them a bit, so that we reduce, for example, the number of nodes, or we reduce the stresses, so that we really make our rules flexible so that the output is what we really want to do. This is for structure. Another example is facade. For a building, facade is it was one of the largest capital cost of a building. Facade is expensive. And so optimizing facade is one of the key elements, especially in a building like this where there is a lot of facade because there are lots of surfaces. And so we did quite a lot of studies in terms of how to panelize the facade. Facades can be split, can be cut in several different ways, and each way is more or less efficient of the other. So we ran, again, through generative models, several models, and understood which ones were the the best one in terms of several different parameters, like the number of panels, like the nodal connections, and so on. And so we found the most efficient facade panelization that would then give the desired outcome with the minimized cost and construction time. But then the fun is when you put the two together. This slide was presented earlier, but effectively, when you try to optimize structure is one exercise. When you try to optimize facade is another exercise. But when you try to optimize the two together, that's when the fun happens, because you can then, only 9 generations of optimization, or, of double optimization, you can really cut, well, in this case, 40% less nodes, 30% less weight, 80% less variation, which effectively means fastest construction, less materials, and easier construction, which then are directly proportional to cost and capital expenditure. So this is a couple of weeks ago on site. This picture was done by the contractor, BAM, but it's to show that all the technology I've just shown is about building things. It's not a theoretical exercise. It's real. It's what's happening. It's being built, and it's going to be finished soon. And if our industry is famous for effectively 2 things, being late and being over budget, this building is not late and it's not over budget, which is quite an achievement considering the complexity of the building. But then again, our initial exercise wasn't about designing and constructing an efficient building, because building is only part of it. What I've said so far could be applied to any type of building, to an office building, to a stadium. You can do exactly the same. What we want to do is design a great space. And when you do a great space, when you think about a space and not only a building, then the problem becomes quite more interesting, because it's not only about better design and construction, money, capital cost. It's not about better performance, sustainability. It's about how the building performs over its life, but it's about a better outcome. And what's been missing in all the slides I've presented so far is the outcome bit, because effectively, at the end of the day, buildings are used by people. And people is, the design should be people-centric. Of course, it should be efficient in construction, or of course, it should perform at best as it could, but it needs to be for people. And so why, instead of thinking about designing buildings, we don't think about designing spaces, designing destination? Because that's what we want. Realistically, we want people to enjoy the space. We want the building to function for what it was designed for, and in this case, it's an exhibition space. And it's not only an exhibition space. As every building, this building will be used for several things all at once. It can be used for exhibition spaces. It can be used for press releases, for TED Talks, for launches of products, and it can be used for everything all at once. And so when you do that, you have different people using the building at different time, at different speeds, at different, in different scenarios through different routes. And what becomes interesting is then, well, we spent the last about 15 years trying to understand and to model how people behave. And we did through extracting a lot of data on all our buildings from through CCTVs, through Bluetooth, Wi-Fi, social medias, how people move in their building, in their spaces, and we're now able to include all this real time in our modeling. And so once you have, and you can do it at the very beginning of the design, as soon as you have an idea of the spaces, you really can start modeling, well, how do people perceive this space? And this is a modeling, one of many we've done, but it's only what happens after a TED Talk, for example. And after a TED Talk, people start leaving. And we can model real time what they see, how they feel. Is it warm? Is it cold? Do they stop for the elevator? Do they not? Do they stop talking? Do they go to the cafe, to the toilet? What do they do? And we're able to do it at the very beginning of the design, which means future outcomes, which is how people will perceive the building, are part of the design now. And we can change the design real time. For example, move the lifts. They're clearly a pinch point in this model, and see what happens, and see what happens to the design. So that's quite exciting. And once you've done that, the next step of VR and applying VR to the building is just almost a small one. Once you can model what people do inside a space, you can then effectively model a day in the life of the building. You can pretend you go to a TED Talk and really visit the building, and really visit the building with people who are doing different things, are going in different places, and you can see, if you are the owner, for example, or the developer, you can see how the building would feel, how the building, would function. Because realistically, as we said before, how buildings feel, how people feel inside the building, how they behave, effectively then it's related to revenue, it's related to how often people want to come back to the building, and how people will want to experience it. So again, it's not only about design and construction, it's not only about performance, but it is about outcome. It is about how the space will be used. And what we talked about is only about a building. Imagine the 5,000 of them, or imagine applying the same thinking, the same technology, the same data to how we design, or we change, or experience cities. That's the real challenge. So that's it for us. Make anything, absolutely, but use technology to bring future outcomes to what you're doing today. Thank you.